Well, hello again and welcome to the VK6CS Fun with Amateur Radio channel. I'm afraid I've still got a bit of a cold. In fact, it might be worse now than it was last week, so if I sound a bit croaky, a bit croakier than usual, that's why. Okay, well, I can hear you screaming how much more of this looking at meters must we endure. Well, I think this is probably going to be the last one, because I've taken out the soft start bird's nest. In fact, I've got it right here, and I would say bird's nest is just make sure the HT's off. I don't want any wires dangling in it and livening me up with about 3,000 volts. Right, there we go. There's the soft start bird's nest that I've removed, and I gave it up as a bad job simply because it was too much of a balancing act trying to get the relay to not buzz and the inrush current low enough, and it's too much juggling around. And I thought, well, I was trying to do it as simply as I possibly could. I just wanted to use a relay, a couple of resistors, but I've ended up having to do it the right way. Okay, well, I'll show you what the right way is, but first of all I'm going to fire it up, and you can see how much nicer it comes on. It will come on quite smoothly. Do about 2,200 volts, and then you'll see it will shoot up to about 2,800 as the relay comes in and shorts out the soft start resistor. And I'll show you it working, and then I'll show you the bits, and then I'll draw the circuit diagram and show you what I've actually done. Okay, ready? Again, you know, to put your fingers in your ears. There should be no blinding flash, no instant darkness. Everything should be spot on. Yeah, look at that. There we go. 2,000 volts, 2,200, and there's the relay kicking in and taking it up to the maximum HT voltage. That is so much smoother. No nasty inrush, no lights dimming, and that really couldn't be happier. You know, if I was a little bit closer, I would probably be able to hear it chuckling. Okay, so I'll just show you what the HT voltage is, as usual. Not you need to see it, but you can see it indicated on the meter. It's just a whisker under 2,800 volts there. Remember, this is times 100. I'm actually going to go to, I don't know, maybe Officeworks. I might be able to get some transfers or something to just put a little times 100 in there. So 20 is 2,000, and then the 200 volt segments there. So it's 2,200, 400, 600, and you can see it's just a whisker under 2,800 volts indicated. So I've got to reach over the camera here. So this is always, you know, not keen on leaning over cameras and extending my arm over a high voltage power supply, but here we go. 2.77, 2,770 volts, which is just a whisker under 2,800, isn't it? So the panel meter's indicating correctly, and the power supply is starting really nice and smoothly. So what have I done? Okay, well, let's see. Now we come over to here, and we can see it's still a lash-up, of course, because this is just a proof of concept. So at the moment it's still got hang on, to be on the safe side, I'll just turn that off. I've still got I've got some thin wires here. I mean, this is just ratty thin wire. It's just and this is as well not the way it's going to be connected. That's just a proof of concept lash-up. And what do we have? Okay, well, this is the new arrangement. There's only one resistor, this flat resistor here. This is actually a 100 ohm flat pack resistor. It's a pulse resistor, and it's rated at 2 kilowatts. So you can pulse this at a couple of kilowatts, no problem. If you want to use it as an ordinary resistor, I think it will run all day and all night at 200 watts. So that's never going to be unhappy. What actually shorts out this resistor is a delay relay. And this relay here, see there's a little blue wheel on the top? That will allow me to adjust from 0 to 10 seconds of delay, and if I change the setting on it again, I think it's 10 to 50 seconds, or it might be a minute, something like that. But this is a timer relay, and it's a delay on relay, so I've set that for, I don't know, a few seconds probably. I looked at the meter earlier on and I saw where the inrush current finished, the high inrush current finished a little bit before a couple of thousand volts, and it slowed right down, got up to about 2200, and I thought, yeah, that's fine, and arranged for the timer relay to short the resistor out at that point, so there wouldn't be very much, the contact's not going to see very much current. Okay, I could have left it, it will go up to about 2400, and sort of bottoms out there. And I might adjust it just so that it will kick in then, but I'll do that tomorrow, if I do it at all. Right, excuse me. Now initially I wanted to do it with really cheap bits, a couple of wire wound resistors and a cheap relay. I've ended up using some fairly expensive components. These resistors are about 75 bucks. Now I didn't buy this, I found this in my junk room a couple of days ago. It was part of another project. I didn't actually, that value wasn't a design value. I just put it in there and it works fine. So 100 ohms, 2 kilowatt pulse resistor is doing a great job, and that's never likely to fail. I got these things I didn't want to use, a timer relay, a delay relay, because they are these, believe it or not, you can get them on eBay for about $5, but $5 or $6. But to buy them new from, well, that was new, but to get them from some of the big electronic outlets like Element 14 or RS, these are about $200, these things. Anyway, I happened to get 2 of these for nothing. So I've got this one here, it plugs into this DIN rail mounted socket, and I've got another identical one, brand new in a box. So if this one fails, I'm laughing. I might even leave the other one cable tied inside the amplifier, so in the unlikely event this fails sometime in the future and I've forgotten all about having another one of those, I'll take the side off it and there'll be one of those, a new one of those, just cable tied in there. So it plugs into this relay plugs into the base. This is a spring clip that holds it in position. So that's that. Now the good thing about this is that this runs on 12 volts AC. It would be better if it ran on 240 volts AC, but because it runs on 12 volts AC, I can put a little transformer in. This is about 200 milliamps this draws. Put a little transformer in, so across the AC feed to this circuit, so it'll be on the HT side of the fuse, but on the main side of the resistor, if you see what I mean. It'll make more sense when I draw it in a second. And the good thing about it is that if the AC just drops off, this will immediately drop out. And if the AC chops back on again, this, because it's dropped out, will prevent the inrush current blowing the fuse. So if it was DC powered from one of the smaller supplies in the amplifier, say a DC relay supply, then it may be that this wouldn't drop out quick enough, and if the AC dropped off and then came back on again, this would still be latched and it'd blow the fuse, because the resistor would still be shorted out. But because it's AC powered, it's great, because it will drop off as soon as the AC drops off, and it'll start timing again as soon as the AC comes back. So that really is the right way to do it. It's an expensive way of doing it, so you probably won't see that in many of the commercial ham amplifiers using these things and using these big pulse relays, resistors. But it's got to be, it'll be extremely robust and it'll work extremely well. Well, it does work extremely well. What I've actually done to fudge the 12 volts AC into this, onto the coil of that, is I've actually for the first time fired up my GS35B filament transformer. So this is 240 volt to 12.6 volt 3 amp. This is the only thing that the only transformer I've got that can provide sort of 12ish volts AC. So it's just a temporary lash-up, just to run my timer relay. And those wires you can see there are the different mains voltage tappings, just hanging in the breeze there. So I'm going to be very careful not to brush against those while I'm doing anything. Otherwise there'll be another humorous outtake. Right. Right, so there we go. As you can see, even though it still looks like a bird's nest, it's orders of magnitude tidier than that other absolute bloody mess. And it seems to work extremely well. Right, so the circuit diagram. I know you're all poised. You're all waiting on the edge of your seat. You've got your popcorn. Well, here goes. Let's not keep you waiting any longer. I can almost hear that drool hitting the carpet. Hang on. Right, so if we come round here, I've done this so many times I get it wrong every bloody time. I should put something on the carpet actually to mark the spot. I think that's about right. That's the wrong way as usual. Get in there. Okay, I've got a cable on the floor which, there we go, I should know that it's just to the right of the cable. Okay. Right, so what does the circuit look like? It looks a lot like this. Got the mains coming in like that. Goes through a 10 amp fuse. I've changed that from an 8 amp to a 10 amp. And then comes along like that. And it goes through my 100 ohm 2 kilowatt pulse resistor, and that then goes into my HT transformer primary like that, and there's the secondary there with the high voltage. Now this has a relay contact across it, like that. So you can see this is so much simpler, and has a timer relay. Actually, I'll just make sure that's still in shot. Yeah. Now I'll try not to move too fast. Getting to an age where I might not have a choice, but I don't want to move too fast and interfere with the focus. Right, now here we have, I'm going to have to get another one of these pens. Here we have our timer relay. That's a little white unit with a blue wheel on the top. This contact is inside that timer relay. Okay. I'll do my Mr. Garrity impression again. Okay, so that contact is in that timer relay. So here I have a little transformer, and I'll put across the 240 volts like that, and this gives me my 12 volts AC to run my timer relay. So if this fuse blows, that AC drops off altogether. If this AC drops off here, this will immediately drop out. So if the AC just chops off and chops back on again, as it's prone to do in the hills where I live, as soon as it chops off, this relay will drop out. As soon as it chops back on, this will start timing again. So there's no way that the power can drop off, come back on, and this still be energized so that it blows, the inrush current would then blow the fuse. So there we go. It's a nice simple circuit. It's much simpler than the other circuit, and that's the proper way to do it. So very well rated 2 kilowatt pulse resistor, 100 ohms, and a timer relay. And you saw how well that HT came on. It's as smooth as silk. It's so smooth you could use it as a pillow if you were completely psychotic. In fact, it's so smooth, I might just show you that again. I just can't, I just can barely contain my excitement. And I think this is going to be the last, this will be the last video with the meters in, because I can draw a line under this and move on to the next bit, which is the, I haven't made my mind up yet, probably going to be the RF relay switching part of it. So ready? Remember, fingers out of ears. Look at that. That is just peachy. Click. There we go. So that'll work like that forever and a day, I would think. Okay, well, I hope you found that interesting, and as always, thanks for watching. And if I don't fall asleep and fall into this thing head first, I'll see you next time.